Before assembling the apparatus and commencing the Grignard reaction, you should be aware that there are two principal types of dropping funnel. The traditional type of dropping funnel should be normally closed off with a calcium chloride guard tube. However, you are more likely to be using a pressure equalising funnel, such as this one. As the name suggests, it's a tube linking the top and bottom so the pressure is equalised. And this type of dropping funnel should normally be sealed with a stopper. This particular one is a rotoflow, has a turning tap like that. And the traditional form of the pressure equalising funnel is this one with a regular stopcock. If any of the glassware you're going to use has plastic fittings, they will have been removed prior to being dried in the oven. It's a good idea to take the glassware out and leave it to cool briefly on the open bench before you attempt to take it to your fume cupboard. As soon as the apparatus is cool enough to handle, you should assemble it as quickly as possible. First of all, I'm placing 100 millimoles of magnesium turnings in the flask. Ensure there's no pieces of magnesium adhering to the joint, preventing a good seal. Then adding a Teflon stirrer bar and an adapter. Calcium chloride guard tube, stopper for this side arm, and a pressure equalising funnel for the other side. Make sure when you assemble the apparatus you have the pressure equalising arm like this, otherwise in this position there's a slight tendency for any added reagents to go down the equalising arm straight into the flask rather than being delivered into the pressure equalising funnel. Whilst you're not supposed to secure a quick fit apparatus by the joints, you can see this 3-neck flask has actually been secured by the upper joint, and we've left the upper clamp loose, so when we loosen the lower boss we can slide the whole apparatus up and down, which will allow us to place a bowl of hot or cold water under the apparatus to control the rate of reaction. When you come to attach your condenser tubing to the condenser, make sure you don't get any water anywhere near the joints of the apparatus. Any water getting to the apparatus will defeat the object of oven drying and will act as a competing nucleophile, preventing the reaction from actually occurring. Grignard reactions may be undertaken in either diethyl ether or tetrahydrofuran. In this instance we're using diethyl ether. Whichever solvent you happen to be using, it's crucially important that it is dried. In this case the ether has been dried with sodium wire, and this particular batch of tetrahydrofuran has been dried over a substance called molecular sieve. Whichever one you use, don't be tempted to pour it out before you actually require it, because it will actually absorb atmospheric moisture quite readily. Diethyl ether is extremely flammable, so even though you should be using it in a fume cupboard, it's always worth checking that there are no naked flames or other sources of ignition in the laboratory before you dispense any. Ether is only a solvent for the reaction, so the exact quantity you use doesn't matter, but do make sure you note down the actual volume that you use. In this instance, I'm adding the ether via the top of the condenser, but either the side arm or pressure equalising funnel are perfectly acceptable. With a boiling point of 35.6 degrees C, note how the ether tends to boil in contact with the still warm glassware. I'm now going to prepare the solution of alkyl halide, in this case 1 bromobutane. Helps control the rate of the reaction if the alkyl halide is diluted with diethyl ether. I'm now adding these two reagents to the pressure equalizing funnel, having checked that the tap's closed. You may want to very briefly take the pressure equalizing funnel off, give it a little swirl to mix the reagents. Then I'm going to turn on the condenser water and commence the stirring. At this point it's very useful to have a bowl of ice standing by, just in case the reaction gets a little bit out of hand. So I'm now going to add some of the bromobutane to the stirred magnesium turnings. Perhaps a teaspoonful or so. A good indication that the Grignard reaction has commenced is the formation of some cloudiness within the ether. If it doesn't commence, then you can try using a bit of hot water and keep the reaction. And sometimes it may be useful to take the stopper out of the flask, scratch the magnesium against the wall of the flask to create a nice bright piece of magnesium where the reaction can commence. Occasionally it may be useful to add crystal iodine to encourage the reaction to start. Since the reaction is exothermic, I'm now going to continue adding the alkyl halide from the pressure equalizing funnel in a dropwise manner. Hopefully the addition should be sufficient to keep the reaction ticking over. It starts to get out of control. We just stop the addition of the alkyl halide, possibly even use our bowl of ice. With the addition of the alkyl bromide now complete, most of the magnesium should have been consumed in the production of the Grignard reagent. Grignard reagents are available commercially, but they are fairly unstable because of their high reactivity. It's worth pointing out at this stage, if any water was to get into this reaction vessel, there's a very good chance that there would be a serious fire. I'm now going to prepare the solution of ketone to add to the Grignard reagent. Before doing so, I'm going to cool the reaction mixture in a bowl of ice. It's convenient to dispense the acetone from this wash bottle. Make sure the tap is closed before addition of the ketone. And as with the alkyl bromide, we're going to dilute the ketone in order that the reaction rate is more controllable. With the Grignard reagent now thoroughly cooled in the ice bowl, I'm now going to add the ketone from the pressure equalising funnel. Again, be very careful and add it dropwise. With the addition of the carbonyl compound now complete, we can complete the reaction by heating the reaction flask with some hot water.